right, let's take a look at your homework assignment where we're solving systems by graphing. We'll see how many of them we go through just to kind of give you some more practice and see what's going on. So on number one here, what's really nice is you just want to remember you want to get your equation back into this form. Y equals, A plus BX. Okay? A and BX can be flipped around. But the key thing you want to be able to do is identify the y-intercept A and B as your slope. Because remember that slope is rise over run. I like to think about how much you go up plus how much you go down negative by how much you go to the right. So if it is negative, I always put the numerator or the rise as negative. So like when I look at this first one right here, I'm going to switch colors here for a second. So I'm going to graph this one in blue. What I want to do is identify my y-intercept. So y-intercept is at 4. My slope is at -1. I like to always write it as a fraction because then now I'm going to rise -1, mean go down 1 to the right 1. So I start at the y-intercept at 4. So now I'm going to go down 1. Okay, to the right 1, down 1 to the right 1. And I follow that pattern, and I like to do many, many, many points so my line looks fairly accurate. So then I can connect all my dots. Got a little off there, but nonetheless, we get the gist. So then I do the second one. I'll do it in green here. So my y-intercept, is equal to 2. My slope, this is what's nice about my slope, they actually put the -3 where I like it, over 5. So this one I'm starting at 2, but I'm going down 3, 1, 2, 3, over 1, 2, 3, 4, bam. Notice how it intersects right there, down 3, 2, 3, 4, 5. Now if I want to go the opposite direction, I do the opposites, meaning I go up and then to the back 5. So that gives me a sense of what the two lines look like. So I could probably draw off better lines there. But that's my intersection point. So I look on my grid, 1, 2, 3, 4, 5, and then -1. So my coordinate here, is 5, -1, or I like to say x equals 5, y equals -1. And that's it for number 1. Same process with number 2, except this first equation, I got to take this 2x and get it to the other side, so y is all by itself. So y equals 3 plus 2x. Okay, so on this one, my y-intercept is 3. My slope is 2 over 1. So y-intercept is at 3, slope 2, 1, 2, 1, 2, 1. Do the same thing going down. So I get a good idea of what my line is looking like. Look at that beautiful line. Do the same thing with the next one. But this one's nice, y is all by itself. So my y-intercept is -4. My slope is 1 over 3. So I start at -4. 1, 2, 3, 4. Sorry. Got a little distracted there. Then up 1 to the right 3. Up 1 to the right 3. Well, we can see the line's not crossing the blue one, so I got to go backwards. So down 1 to the left 3. Down 1. Ooh, did I do something wrong here? It's kind of interesting. Well, we'll see. Maybe Mr. Parts did some numbering off wrong, did he? Oh, Mr. Bartz, what did he do wrong? Just to let you know, this green line is done correctly. Many of you may have saw this, but my blue line, see, Mr. Bartz even makes mistakes, even in the video, made a mistake. When I move the 2 to the other side, this is a big boo-boo here. Well, it's not that big, but this should be not plus, but minus. So my slope should have actually been a -2. I'm going to regraph that line. So right here at 3, sorry, I want to switch back to the color. I swore I hit that, but somehow, let me just make sure the colors match. That's just me. So I should have been going down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Try to make sure, just to make life a little bit easier, that these should mostly intersect at nice points. That's why I kind of knew I screwed up. It happens. Mr. Bartz does that from time to time. 3, negative 3 is my point. So x is 3, y is negative 3. Now, one of the things I haven't done, but you can from time to time, is check these. Plug them in. 2 times 3 is 6, plus negative 3 is 3. That's correct. 1/3 times 3 is 1. 1 minus 4 is negative 3. That is correct. I have it right. All right, let's take a look at the next 2. So, on this first one, I'll do in blue here. Our y-intercept is 5. My slope, negative 1 over 1. Start at 5. 1, 2, 3, 4, 5. Down 1 to the right 1. So you can see how I'm graphing all those points. Get an idea of what it's looking like here. Now, x plus y equals 9. Let's hope Mr. Bartz does this right. Got to bring that to the other side, which makes it negative. So y equals 9 minus x. So when I do this one, my y-intercept is at 9. My slope is at negative 1 over 1. I'm starting at 9. Wow, 1, 2, 3, 4, 5, 6, 7, 8, 9. But my slope happened to be the same. And some of you might be going, well, Mr. Bartz, if I have the same slopes, we know from back in chapter 1 and chapter 3, same slope, or slopes have, if lines have the same slopes, they're parallel. So this one we have no solution, parallel lines. All right, let's jump to the next one. I'll switch some colors here. Ooh, on this first equation here, I'm going to do something different. I'm going to move this negative y to the other side. The reason I'm doing that is I'll have x equals 7 plus y. I do that because I like the y positive. That way I don't have to forget about dividing by a negative number. Subtract 7. So y equals, since that's gone, x minus 7. So I start at negative 7. 1, 2, 3, 4, 5, 6, 7. Sorry, y-intercept, I'm getting a little fast here, is at negative 7. My slope, 1 over 1. So up 1 to the right 1, up 1 to the right 1. Okay. So I got my line. So what's nice about the other one here, I'll do in purple just to be a little different color. My y-intercept, I can identify it right away as at 1. My slope is at negative 3. So at 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, to the right 1. I got the point of intersection there. It's at 2. And then down 1, 2, 3, 4, 5, negative 5. So x equals 2, y equals negative 5. Just like that, 4 problems done. All right, next one. Ooh, this one's going to be a little more work here. So the first equation, I got to move the 7x to the other side. So 3y equals 27 plus 7x. Divide everything by 3. So y equals 9 plus 7/3 x. So my slope, 7/3, y-intercept is 9. Ooh, I apologize. What's wrong? Should be negative 7/3. Did it again, Mr. Bartz. Oh my goodness. If you move that over to the other side, we're subtracting it. Oh my goodness. Almost made that mistake twice. Glad I caught it now. So I start at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going down 7 to the right 3. Down 7 to the right 3. Down 2, 4, 6. Ooh, I actually run off a little bit here, but I got my line. Then if I do this one here, I can move the x to the other side. So I have y equals 5 minus x. Oh, glad I got that right. So my y-intercept is 5. My slope, negative 1 over 1. I'm starting at 5. 1, 2, 3, 4, 5. Okay, down 1 to the right 1, down 1 to the right 1, down. Look at that. It's actually one of the points. That is so nice. Does make this a little bit easier to do. So I just need to know where that point is located. So 1, 2, 3, up 2. So it's located at 3, 2. So x equals 3, y equals 2. So I can plug it again back in, and I get 21 plus 6, because 7 times 3 is 21, 3 times 2 is 6. That adds up to 27. 3 plus 2 is 5. Beautiful. All right, so next one here. So on this one here, I got to move the x to the other side. So I have 2y equals 6 minus x. Divide everything by 2. So I get y equals 3 minus 1/2 x. Ooh. So my slope is 3. So 3 over 1. Oh, I'm sorry, not my slope is 3. Mr. Parts, my goodness. I've almost made 3 mistakes here now. Sorry about that. When I get too close to the edge, it jumps. So slope is negative 1/2. Let me rewrite that. Slope, negative 1 over 2. Y-intercept is at 3. Okay. So start at 3, down 1 to the right 2, down 1 to the right 2. Do that process all the way through. Okay. So go do the same thing going the other direction. I got my line. Okay. So, when I do the next one, ooh, look at this. Isn't it the same? Slope is negative 1/2, y-intercept is 3. So it's going to give you the exact same line. So we get the same line, and then I like to say infinitely many solutions. I think on one of your worksheets, it will give you the equation to say all the points on this line. That's why it's infinitely many solutions, since the line can keep going, but it's got to be all the points on these lines, or on this, or both of these lines, which is the same line. All right, if I flip to the next page, okay, we have a few more, but we got a little more algebra to do. Same process though, okay? So on this one, I got to move the 3x to the other side. So I'm going to kind of move it up here so it gives me a little more room. So I have negative 4y equals negative 12 minus 3x. Then I got to divide everything by a negative 4. So y equals 3 plus 3/4 x. So my slope is 3 over 4. My y-intercept is 3. So there's my y-intercept 3, up 3 over 4, up 3 over 4. Down 3 to the left 4, down 3 to the left 4. Okay? Make sure those are connected. That one's done. So on the second one, what's nice is if I move the 2x over, I have the equation y equals negative 8 minus 2x. So my slope is negative 2 over 1. My y-intercept is negative 8. So 2, 4, 6, 8. So I'm going right 1, down 2. Well, that's not going to help me much, so I got to go backwards. So up 2, but to the left 1, up 2 to the left 1. Right there is where they're intersecting. So where is that point located at? Negative 4, 0. So x is negative 4, y is 0. So again, I can check. If I go right here, 3 times negative 4 is negative 12 minus anything times 0, 0. That's negative 12. 2 times negative 4 is negative 8 plus 0, negative 8. My answers are correct. All right, let's fly through the last couple here. Like this one here because my slope is just 1 over 1. My y-intercept is just -2. There's -2. Slope is 1 over 1, up 1 to the right 1. Okay. So I can go backwards. Should be hopefully enough points to give me a good idea of what it looks like. So then on the second graph, I gotta move the 2x to the other side. 5y equals 25 minus 2x. Divide each term by 5. Y equals 5 minus 2/5 x. So, slope, -2/5. Y-intercept is 5. So up 1, 2, 3, 4, 5. Down 2 to the right 5. Look at that right away. Like that. So where's that point at? 1, 2, 3, 4, 5, 3. So x equals 5, y equals 3. And again, I can plug it back in and check. 5 minus 2 is 3. 5 times 2 is 10. 5 times 3 is 15. 10 and 15 make 25. All right, this one's nice because here my y-intercept is 0. Slope is 1/3. So I'm starting right at the origin, up 1 to the right 3. So I do that, or down 1 to the left 3. Graph those. Beautiful. Then on the second one, oh, this is really nice. Y-intercept is at -5. Slope is at 2. So -5, 1, 2, 3, 4, 5. Up 2 to the right 1, up 2 to the right 1. There we go. There's our intersection. It's at 3, 1. So x equals 3, y equals 1. Again, I could check. 1/3 times 3 is 1. Beautiful. 2 times 3 is 6 minus 5 is 1. Oh my goodness. We're now getting in a groove just as we're getting close to the end. All right, so let's move that over. Make sure I make it subtraction. That's been my issue today. So slope is -1 over 1. As always, I can put a 1 in front there. Y-intercept is 6. So 1, 2, 3, 4, 5, 6. So slope was -1. So down 1, left, right 1. There's that line. So then on this one, got to switch colors here. Go to blue. So I'm going to subtract x. So I'm going to kind of move it over here. So I have -3y equals -6 minus x. I got to divide by -3. Got to watch this carefully. Y equals +2 plus 1/3 x. So my slope, 1/3, my y-intercept is 2. So starting at 2, up 1 to the right, look at that, 3, right on that point. So that is looking like it's at 3, 3. X equals 3, y equals 3. Do a quick check. 3 plus 3 is 6. 3 minus 3 times 3, well, that's 9. 3 minus 9 is -6. How about that? Got all those right. Excellent. All right, so hopefully this helped you out a little bit.